All right. I'm really sorry that I didn't do these in class. There's actually another type that we didn't do in class, which was rationalizing the denominator. Ms. Bainey made one video on showing you how to rationalize the denominator when you get something like this. That's something that should have been in the lecture, and it wasn't. Again, I don't want to make a habit out of forcing you guys to watch videos to learn the things on the assignment. I want the videos to only be about how to do the problems on the homework. But in these cases, we're going to ask you to kind of learn them on the videos, I guess. We can maybe look at them next class a little bit. But one of the topics I didn't get to in class was simplifying complex fractions, and you should know how to do these. This is a review problem. You know, how do we handle fractions within fractions? That's what a complex fraction is. Well, on the top, we're just going to think of these as little fractions. 1 over 1 plus 3 over 7. Sorry, 1 over 7. 1 over 1. And over here, 2 over 3 minus 3 over 1. Get a common denominator, multiply by 7 over 7. Get a common denominator here. Combine our fractions. We want to get the top into a single fraction, 10 over 7, over. We want to get the bottom into a same single fraction, 2 minus 9. What's 2 minus 9? Is that negative 7? No, negative 7. And to divide fractions, you take the top fraction multiplied by the reciprocal of the bottom. You get negative 30/49. So if you can do that with numbers, you should be able to do it with rational expressions. X minus y over x over y plus y over x. So the directions on this example would be to write this, would just be to simplify. A simplified fraction does not have fractions in the numerator and denominator. So to work this, leave this x over 1 alone. This is going to be y over 1 over. Let's get a common denominator on the bottom here. Multiply by x over x, multiply by y over y. So this is going to be x squared plus y squared all over xy. Remember, the lengths of these fraction bars are important, so make sure you make that thing nice and long. This is x over 1 minus, I'm going to take the top fraction, multiplied by the reciprocal of the bottom. Okay. All right. So now I have x over 1 minus xy squared over x squared plus y squared. Let's get a common denominator. I'm going to multiply this expression by x squared plus y squared over x squared plus y squared, getting a common denominator. And I get x, and distribute it, x cubed plus xy squared minus xy squared over x squared plus y squared, which gives me x cubed over x squared plus y squared. Now, unfortunately, and I know you guys hate these, but we do need to consider restrictions. In the original problem, x and y could not be equal to 0. And if you noticed, whenever I multiplied by the reciprocal right here, that xy that couldn't be on the bottom kind of moved up to the numerator up top, where it can be equal to 0. But in this problem, x and y can be equal to 0. But over here in the original, it's not supposed to be, so we have to have these extra restrictions. Again, guys, I'm sorry about all these restrictions kind of add in a level of complexity that you wish we didn't have to worry about, but, you know, what can you do? All right, I was going to stop there, but I just want to show you maybe one more. Example, simplify. X to the negative 1 plus y to the negative 1 over x plus y quantity to the negative 1. So first of all, I want to illustrate that you cannot just For example, take this x, let's leave this alone. I can't take this x to the -1 and just move it down here to the bottom. And I want you to understand why not. It's because of this addition sign here. This isn't a factor of x to the -1 that can be moved down to the bottom because of the plus sign. Now, however, I could move this entire thing up to the top, but I'd have to keep it like this. Like I'd have to put that in a parenthesis and then move up this to the top and make it a +1. So you could do that, but I'm not going to do it that way. Here's how I'm going to solve this. Remember the definition of a negative exponent. Although you can't move it down to the bottom, to this denominator down here, you can move it into its own little denominator as a fraction up top. And this can be written as x plus 1 to the 1 power. So I prefer to just write it like this. Now we can see our fractions and solve it kind of the way we always solve these types of problems. Common denominator on the bottom, on the top, excuse me. So it's going to give me an x plus y over xy over 1 over x plus y. I'm going to take the top fraction multiplied by the reciprocal of the bottom. So I'm going to get the quantity x plus y squared over xy. Restrictions. In the original problem, x cannot be equal to 0, y cannot be equal to 0, and right here, we know x plus y cannot be equal to 0. In the final problem, x can't be 0 and y can't be 0. Those two things are implied. However, x plus y can be 0. So the only restriction that we need to have is that x plus y cannot be equal to 0. Again, sorry about the video, 7 minutes in length. Oh, waste of your time, right? But you do need to know how to work with complex fractions. And please watch the videos that Miss Bainey put up about rationalizing the denominator. Like I said, we can we'll revisit with that. We'll go over that idea at the beginning of class next time. But the last two problems on the homework, you are required to have that. So good luck.